Hello guys, in this video I am going to explain the solution of this question number 12 from chapter 8 from the book Engineering Circuit Analysis by Hayt, Kemmerly and Derwin. So this question says that the current IT is flowing through the 1 ohm resistor and the current is given by this and the current is in milliampere. And now we need to determine the value of T for which the resistor voltage magnitude it is equals to 5 volt, 2.5 volt, zero point 0.5 volt and 5 millivolt. Now over here, since the resistor and the current is given, so simply to determine using the Ohm's law, we know that Ohm's law, as per Ohm's law, V is equals to IR. So over here Vt will be equals to R IT, right? And now R is 1 kilo ohm, so 1 into 5 e power minus 10t, it is equals to 5 e power minus 10t, right? Vt, and since it is milliampere, so this will be millivolt, right? Because our resistance it is in ohms and current is in milliampere, so Vt will be in millivolt. Now the problem is that the question says that we need to determine T for which the voltage magnitude is equals to 5 volt, but over here the maximum possible value, like for we know that the possible value, like if we have something like e power a minus a can be any value, like a can range from infinity, a can range from this 0 to infinity, right? Because there, like the voltage cannot be negative, right? So if we consider this thing, so the range of this exponential e power minus a, the range it will be from 0 to 1 only, because if you substitute over here e power a, if you substitute the value of a as 0, then it will be 1. If you substitute the value of a as infinity, then it will be 1 upon e infinity, and it will be 1 upon infinity and 0. So you can see the possible values of this e power minus a, it will be 0 to 1. And if it is 0 to 1, then it simply means that the possible range of this Vt, it will be 0 to 5 millivolts. So it is not possible to have a volts. So over here there must be some mistake in the question, and the mistake it may be like this milliampere, either it is ampere, or this is kilo ohm. So we over here we will assume that the current is milliampere and the ohm, the resistance, it is not 1 milliohm, it is 1 kilo ohm, right? So if we assume this, then this 1 kilo ohm it will be like over here in this, instead of this 1 we will put 1 cross 10 power 3, right? And then this millivolt it will be then converted into, like, this 10 and this milli will then cancel out, and we will get the answer in volt, right? So and then the range of this Vt it will be from 0 to 5 volt. So we need to like, there must be some error, some mistake in this question, that either the register it is 1 kilo ohm or the current it is in ampere. So over here let me assume that the resistance is kilo ohm, right? So over here, now now the question says that we need to determine the value of T for which the voltage is 5 volt. So it means we need to determine the T, and Vt is given. So rearranging this, what we can do, we can take the natural logarithmic of on both sides, so we will get this 5 ln, right? Or before this let me bring this 5 over here. So it is Vt upon 5 equals to e power minus 10t, right? And then taking the natural logarithmic of this, it will be Vt upon 5 equals to minus 10t ln E. Now ln E, we know that ln E, it is equals to 1, because ln is simply our logarithmic E. So it is 1, right? So this term will be 1. So we get ln Vt upon 5 is equals to minus 10t. So it means our t, it is equals to minus upon 10. So this is the formula to calculate the time for different values of v. Right now, if I plot a graph like a table, our v, it is given as vs, that we need to determine the value of t for 5 volt, for 2.5, for 0.5, and it is they are volts, and 5 millivolt. So for this we need to determine t, right? So using this formula, for the first case, for this case, we will get t is equals to minus ln, it is 5 upon 5 upon 10, right? 5 upon 5 upon 10. So over here you will get it as minus ln 1 upon 10, and the answer to this, it will be, let me calculate it on a calculator. So it is 0, ln 1 is 0 upon 10, so it is 0. So at 0 seconds we will get the voltage at as 5 volt, right? And this we can verify if you substitute t equals to 0 in this case. So if you substitute t equals to 0 over here, so this term, it will be e power 0, means it will be 1, and vt will be 5, right? Now coming to the next one, 2.5. So over here again using this same formula, so over here instead of this 5 we will have 2.5, and if it is 2.5, then this will be 0.5, right? So 0.5, it is this term, it will be 0.693, right? So it means it is it is 0.0693 seconds, right? Or we can say 69.3 milliseconds. So it is 69.3 milliseconds, right? Now coming to the next one, 0.5. So again substituting this 0.5 in this, so we will get, like over here I can remove this, it is 0.5, right? So over here this term, it will become 0.1, right? So 0.1, so it will, from this we will get over here, it is 0.1, it is 2.303, right? Or 2 point, let me write it for two more decimal places, 26, right? So this term, it will be 0.23026 seconds, right? So in milliseconds it will be 230.26 milliseconds. So 230.26 milliseconds. And now for this 5 millivolt. So over here we will 5 millivolt, we can write it as 0.005 volts. 0.005. So substituting this over here, we will get 0.005, right? So it will be 0.001, right? And solving this one 0.001, so we will get this time as 6.90776, right? So it is 0.690776, so it is 690.776, so it is 690.776 milliseconds, right? So you can see that as the time is going, like as the voltage is decreasing, the current is increasing, right? From 0 seconds or 0 milliseconds to 690, we can also say it as 0 milliseconds, right? So the current is increasing. So with the increase in the current, with the increase in the time, the voltage is decreasing from 5 volt to 5 millivolt, and this is what this graph is also indicating, because this e power minus 10t, it is the exponential decaying function, right? So this is part A of the question. Now part B of the question says that graph the function over the range 0 to 1 second. So we need to graph this function. So if I plot this it, if I plot this it on a graph, function over, so our it, it is given as 5 e power minus 10t, right? So if I want to graph it, I know that it is the graph is exponential decay function, right? And when we want to draw the exponential decay function means this graph, then we know the curve, that the curve will be something like this. The only thing that we need to mention it out is this point. What will be this point, right? And since it is in the question it is asked that we need to graph it for this range, so it means that we need to determine at least what is the value of it at t equals to 0, and we need to determine what is the value of t at what is the value of I at t equals to 1 second. So substituting the value of t as 0 in this, so we will get I0 is equals to 5 e power minus 10 into t 0. So it is simply 5 milliamperes, right? So we put it as 5, right? Right. So it is milliamperes. It is in milliamperes. Now in the second, like for 1 second, we put it as this. So for this we get 5 e power minus 10, and 5 e power minus 10 is, let me calculate, e power minus 10, it is e power minus 10. So this we get a into 5, right? Into 5, right? So for this we get 0.000226 milliamperes. So you can see it is approximately 0 milliampere. So it means our, like, if this is our 1, if this is our 1 second, this is our 0 second, then our graph will be almost decay, it will be almost 0, right? So at t equals to 0 it is 5 milliampere, and at t equals to 1 second it is approximately equals to 0 milliamperes. So this is the graph, and this is the answer to the second part of the question, which says that we need to graph a function over the range this using linear scales for both axes. Now the third part. Now the third part says that we need to draw the tangent to the curve, to this particular curve, at t equals to 100 milliseconds. So we will plot a tangent at this point, t equals to 100 millisecond, and then we need to determine where the tangent intersects the time axis. So it means that at for this graph, at t equals to 100 milliseconds means 0.1 second. So something over here, right? Let it be 0.1, right? So at this point, if I draw this, then at this point I need to draw the tangent. I need to draw the tangent something like this, means something like this, right? And after drawing the tangent, I need to determine this location. I need to determine what is this location, right? Obviously the current at this point, the current will be 0, so I just need to determine the time, right? So the coordinate of this will be time. What will be the time? X-axis, on x-axis we have time, so I put question mark. This we need to find, right? And let me put in fact t dash, and on the y-axis we have I, and over here I is 0, right? Similarly, if I put a coordinates of this point where we need to determine the tangent, so the point coordinate it is 0.1 comma, and what will be this? Y. Now to get this value of I, simply what we can do, we will use this formula. So over here I will substitute the value of t as 0.1, so it will be 5 e power minus 10 into 0.1, so it is 5 e power minus 1. So this we will get as 1.84 milliamperes. 1.84 milliamperes. So over here the second point will be 1.84. So this is the coordinates of this point where we need to draw the tangent, right? After that, like whenever we want to draw the tangent, the straight, because tangent is a straight line, so straight line, to get the equation of a straight line, we need to determine the slope. So how we are going to determine the slope? By taking the differentiation of this, because we know that the slope m, it is dy by dx. We just need to take the differentiation, right? And the differentiation of the curve, like if this is the curve on y-axis, on y and x-axis, then we need to take the differentiation of this curve, and then after taking the differentiation, we need to substitute the value of, like if we know x, then substituting the value of x1 in the differentiation, we will be able to get the y, right? So let's check how we can do. Now over here is on the y-axis we have I, so we will put I, and on the x-axis we have t, so it is di by dt. Our I it is this, right? So we need to differentiate this 5 e power minus 10t upon with respect to time, so it will be minus 50 e power minus 10t, right? So this is our m, or simply it is the slope, right? Now since I want to determine the straight line at t equals to 0.1 second, so I will substitute this point t over here, so it will be m it will be minus 50 e power minus 10 into 0.1. So it will be minus 50 e power minus 1. So e power minus 1. So this will be minus 18.39. So my slope of this tangent that I will draw, slope of this tangent, it will be this minus 18.39, right? So now since now I know the slope, so how I can determine the equation of this line? We know that the equation of a straight line can be represented as y minus y1 equals to m x minus x1. This we know, where this x1 x1 y1 are the coordinates, are the coordinates of any point on a line, any point on a line, right? And m is the slope. So now x1 and y1, these are the coordinates of any point on a line. So over here we know that if we are drawing the tangent, then on this tangent is drawn at this point. So already we know the coordinates of this, which is 0.1 and 1.84. So using this equation, we will write it as, like, instead of y we have this I, right? So I minus I1 is equals to m, and instead of x we have t minus t dash, t1, let me put t1. So it is I minus, and I1 is it is this 1.84 and t is 0.1. So 1.84 m we got, it is minus 18 upon 39. So minus 18 upon 39 t minus 0.1. So now solving this equation, what we will get? We will get like I equals to, it is minus 0.8, it is 18.39 t, and then taking this 1.84 on the right side, we will get 1.84, and then this 0.1, it is plus 1.839, right? So plus, it is plus. So it is I is equals to minus 18.39 t plus 1 point, like if I take the sum, so it is 976 3.679, right? It is 3.679. So this is the equation of the tangent, Now it is asked, like it is asked in the question, that we need to determine this point where the where this a tangent is going to intersect the time axis, means where current is 0. So current is 0 means we will substitute the value of I is 0, right? So we will substitute the value of I as 0. It is minus 18.39 t plus 3.679. So if you solve this, you will get t is equals to 0.02 seconds, right? Not 0.02, it is 0.2. So 0.2 seconds. So our t1 it is 0.2 seconds. So now it means, if going to the graph, it means this t dash, not t1, t dash, because I have taken this as t dash, so t dash. So over here it means t dash is 0.2. So we can replace this as that this point is 0.2 seconds, right? This is 0.2 seconds. right? So this is answer to the third part of the question, where we need to draw the tangent at t equals to 100 milliseconds, and then we need to determine where the tangent intersects the time axis, right? So this is all. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.